Hello YouTube world, this is Logic Crazy and I'm Jonathan, and here's yet another tutorial on creating your very own Java chess engine. So in this tutorial we'll focus on creating this rate attack, or filling in this rate attack method, so that we know if a piece is being attacked or not attacked. And basically, if I were retreating and not really attacking, but the other side was attacking me on all fronts with queens and bishops, long-range stuff, and all I had was pawns to defend me, then they are obviously in a winning position because I can't do much about the situation, and they have a lot of control and they can really manipulate me. And so that's why I have a return rating system. So what we'll do is, of course, we'll start off with this int counter, set it off as 0 as always, and in the end we will return the counter. And so we'll start by creating a for loop, and I'm just going to copy this whole switch thing because I'm lazy. There we go. Paste it in there. Now this would go through each item, and what we are going to do is not just switch on this, but we need to first have an if, first change these parameters here. We have all of these. We won't worry about king right now in the attacking thing. So we're going to start with a pawn. Now, how do we know if something is attacking? Well, here's what we could do. Let me put curly brackets around there. We're going to call a few things, so I usually put curly brackets then. Let's change my typing's all over the place. Alright, alpha beta chess dot king position C. If we set that to the I, the location of the square we're looking at, then we can check if that spot is safe. So we'll go to each piece and pretend the king is there and say, would the king be safe if it was there? So basically then we know if we're under attack. And then so we basically do that exact thing. So if not, alpha beta chess dot king safe. If it's not safe, then what do we do? Well, then we say counter, and this is a pawn, let's minus 64. Pick a nice weird number like that. Oh, counter minus equals 64. Should fix that problem. Now, we're manipulating king position C. So we're going to have to record what king position C is beforehand, and then set it back at the end to its original thing, so we don't mess up where the king is and then allow pseudo-legal moves, which means possible moves, but that don't take things into account like king safety. So we'll say int, let's call it temp position C equals alpha beta chess dot king position C. So we set this temp thing, and then at the very end, before we return, we'll say again, alpha beta chess dot king position C equals temp position C. So reset it back to starting location of king position C. Alright, now I'll copy this line and paste it into all of these. There we go. And now all we have to do is modify the number at the end. So rook would be worth 500. This would be worth 300. This is worth 300. And 900. There we go. So now we are and it's always minus because it's a bad thing to be attacked. And now we will add something for the king. We should add something for the king. I just don't need it in an extra case that it needs to look through, because this is just my own thoughts. I don't know if this is actually the case, but a bunch of these chessboard squares are empty, and therefore I'll try case P, case R, go through each one of these, and then check the A one a bunch of times for each of these blank squares when we know it only occurs once, so we don't need to add an extra case that it has to think about. That's just my own logic. I haven't actually checked if that actually is true, but we will add here now that we've set the king position back to regular. If not, alpha beta chess dot king safe, then counter minus equals 200. There we go. And then we'll return counter, but one thing I would like to notice is most of these, except for the pawn, which I figure should be a little lower than its actual pawn value of 100, just for theoretical reasons. But for instance, the rook, if you attack the rook, it's as good as taking the rook. Because if you take the rook, that's minus 500 points for white. And if you capture, or if you attack the rook, it's minus 500 points. And so I think that it would just think, oh, attacking is as good as destroying, which it isn't. So we will return the counter divided by 2, is what I have set. You could take each of these values and divide it by 2 as well, but I just like to keep clean at 900 and such. That is entirely up to you. Now, I believe we had already placed this rate attack method, yes, in 2 places already in the rating. So when you run the program, it will take into account all of those things and make a move. And that is the move it starts out with. Now this happens to be a great opening move, one of the common opening moves that you could make. Now it's playing obviously as white, but we have to switch the colors and stuff, so there's still a few things on graphics that could be done. But that is all for the rating for now. This is a very rudimentary, basic rating system, nothing too fancy. I should caution you, there's much to be improved in this rating system. Obviously, there's only 157 lines, and my latest chess engine has over 800 lines to analyze a position, but I must encourage you to balance your rating system. You can make a better rating system at the cost of extra computational time, and sometimes it's worth it, sometimes it isn't. Sometimes you just want the engine to think multiple moves deep and overcome some of the weaknesses that the rating system didn't realize. And so just be cautioned to come up with a much better rating system than this, but don't make that perfect rating system that takes 3 seconds to analyze one position. So that is about it for the rating system. I hope you have learned something. Until next time, enjoy Java.